Okay, so now what I'm going to do is start the process all over again. I deleted that project, so let's start it over. So I'm going to open up Enterprise Miner. We're going to create a new project, and we're going to put that in the directory that we created called Sharon. See, and this is Sharon. There's nothing else in there. I'm going to hit OK, open. So that's the directory, and we're going to call it Sharon Project, or SH Proj. How about that? We hit Next, and Finish. And there it is. We've now created a file called Share Project. In fact, I'm going to exit out of here, and I'm going to show you how to open it up later on. So later on, when you want to come back, if you look in the directory Sharon, we got this Share Proj there, and all those directories. This is the guy we care about, is Project EMP. So watch this. I'm going to open it up, Enterprise Miner. Open projects. Then we go to Sharon, and we open up the project. We just click on this guy, and there we go. So did you see how to do that, Sharon?
Yeah, thank you.
Okay. Now, the only thing you really need to do is two things with this window. One is bring data in. Well, the way you can bring data in is you first got to know where it is. So you highlight Sharon Project, and you come down here, and this is called the Project Start Code. You click on this guy here, and up comes a window, and you can write SAS code, and this is the SAS code that will get executed every time you open up the Sharon project. So we're going to write, let's open that guy again. Libname, Sharon lib, and we're going to put that in C:, Sharon data. Okay? Do you know what that does?
It'll bring in that the library from that
Right.
location.
That's going to create a library that's going to point to that directory. So you have to hit Run Now, and OK. Don't forget to hit OK. So at this point, SAS now knows that library, and it will execute that every single time.
Okay.
So if I come here and I want to create a new data source and bring it into SAS, I go right-click, create a data source. Now, you guys are dealing with a pretty big data set, aren't you, Sharon?
We are.
Okay, you may have to prune that thing down somehow before you bring this in. I don't think my computer would be able to handle 13 million records.
No, mine bombed out for sure, and I'm sure it's much smaller than yours.
Yeah, so you probably want to take that down a lot. Sample it. Okay, anyway. Let's start this over. Right-click, create data source, hit Next, hit Browse. Look at that, Sharon lib.
Okay.
Double-click. There's your data. You might sometimes have to hit refresh, but it should be there. Highlight it, hit OK, and just hit, the trick here is just hit Next to everything. And there it is. Now the next thing we're going to do is we got to create a diagram. So we're going to highlight the diagram, and we're going to right-click, and we're going to say create the diagram, and we're going to give it any name we want, and we're going to call this one Gin On. Gin, you're going to be famous.
I'm so excited.
Okay, there you go. Gin on. Okay. And now the rest of this is going to be as easy as falling in love. Okay. What we're going to do is we're going to drag this guy onto the desktop. And this is just a SAS data set. And you might want to hit run to load it in, although you probably don't have to. It's a good idea. So let's just load it in there. Okay. And just a second while I shovel some meat in my mouth. Okay. So if you right-click on this guy and hit Edit the Variables, you can see the variables. Now, here we can predict, this is all the variables that we have, and this is predicting who's going to default on a loan, okay? So this is, the bad people are people who default. Credit line age, number of credit line, debt to income ratio, okay, this is all the variables we have. Now if you want to look at the data, you highlight it, come down here and hit Explore. Okay?
Mm-hmm. So you can explore the whole data set at one time if you highlighted everything? Oh, yeah.
I'm chewing just a minute.
Okay.
Okay. So do you see that if you come over here, you can actually see the data. So this is my bad people. So this guy paid me back, and this guy defaulted on the loan. This is the loan amount. This is the mortgage. This is what the reason for the mortgage. This is their job. You can see I got some missing values in here. But this is real-world data, okay? Now, the next thing we do is you come up here to the Utility tab. And you see this guy with the eye on it? Drag him down there. Now, everything I'm doing you can do in like about 50 different places, but I'm showing you to do it the easiest way to remember it. Because what I'm about to do here, you could also do here. But it's easier to do it here because then when you want to go and fix things, you know where to look, okay? So I'll show you what I'm about to do. Okay, so I've dragged this guy. Now I come over here and take this pencil and I click and I connect it. So the data is going to flow from here into this guy here. So let me hit run just to load the data in there. Okay, now what we're going to do is we're going to come over here. It says train, highlight that, and you hit this button right here. And same thing you've seen before, but I like to do it in the metadata node because, like I said, when your diagram gets complicated, you know where to look when you want to say, where did I change that thing? You know it's always going to be in a metadata node. Okay, now SAS doesn't know what the hell to do with this data. He thinks everything is an input variable, but you've decided that you want it to be a target, the thing you want to predict. Okay? Now, you can see that what I would usually do is the default is going to be input. What I recommend doing is actually going over here and changing them all to input. Even though that's the default, it's safe to do it that way. I like to play things safe. So all of these guys are going to be input variables. This is going to be what I'm trying to predict. So are you following that so far?
Uh-huh.
Okay. If at any time you want to throw a variable out, you could come over here and you could say reject it, and your model won't use it.
Okay.
Okay? So the next thing you're going to want to do is tell SAS what kind of variable is it. So what I usually do is SAS says is guessing that most of these guys are interval variables. So I come over here, and I say, yes, they're intervals, and these guys are nominals. Nominals are class variables, okay? And now, let's go back here. Bad, let's take a quick look at that. You'll see that bad is actually a 1 or a 0.
Okay, phenomenal.
So it's a 1 or a 0. So what I usually do when I know it's a 1 or a 0 is I change that to binary.
Oh, okay.
Okay. If you don't, the world doesn't end, but you're probably better off making it a binary. Okay? There's some advantages to that because once SAS knows it's a binary, he'll calculate some new statistics for you, and it will basically once he knows it's a binary, he'll do some things for you that are kind of nice. Okay. Now, what kind of variables can I have? I can have a binary that's a 1, a 0, a yes, a no, a true, or a false. I can have a nominal variable, and that would be a class variable like red, green, and blue. I can have an interval, and an interval is going to be a number. And an ordinal is a class variable that has an order to it, like letter grades on a report card, A, B, C, D, F, okay?
Okay.
So this is, and here's one other one. And then the role of these guys, there's lots of different roles here. But for your purposes of just getting started, I would only use input that goes into a model. Target comes out of a model. You can reject, or you can use ID. That's like a person's name or their social security number, something you don't want to use in the model, but yet you might want to keep it around, okay?
How would you use output?
So if you know those 4 things, you're pretty good. You have any questions so far?
How would you use the output in that column?
Output, what do you mean?
Did you say one of the choices in the drop-down was output? Oh, I thought you said, okay. I thought you said input and output.
No, input is what goes into a model. Target is what comes out of the model.
Oh, target. Okay. Okay, gotcha. That makes sense.
Okay.
So basically the columns in shaded gray are the original values, and then the new are the ones where you changed them. Yeah,
SAS thinks this is what it is. I'm saying this is what it is. Now, I don't have to do this. If I don't tell SAS, he'll use a default value. And his default is going to be this guy. I'm just telling you a best practice is hard-code it. Okay?
Mm-hmm.
So there you go. When you're done, you hit OK. Now, the next thing we're going to do is probably you're going to want to break the data into training, test, and validation. Okay? So come over here to sample and take this guy here, data partition, this guy right there. Drag him on the screen, connect him, and now SAS is going to randomly use 40% of this for training, 30% for validation, and 30% for test. Okay?
Okay.
And what will happen is the difference between validation and test is this. If I train a model like a decision tree, and then I validate it, what will happen is SAS will say, okay, I now know how accurate the tree is, but now I'm going to prune it back using this validation data. So he tweaks the model using validation. Test data is final holdout data that that doesn't affect the model. You don't have to use validation data if you don't want to. Some people just say 70% for training, 30% for holdout, or whatever you want to set it to. You don't have to use that. If just people with a machine learning background tend to like validation data, pure statistics people don't. It's just a matter of taste. Okay, this is a random number seed, 1, 2, 3, 4, 5. And the neat thing about this is if you build a model and then Jen builds a model, if you guys both, if you give your code to her and she runs it, she'll get the exact same answer as long as this random number seed is the same.
Okay. How would
I'll show
you
you
use that
something neat
replicator?
later on.
Okay. I
So-
actually have that code in mind right now, but I didn't know how you reused that 1, 2, 3, 4, 5 value.
Yeah, they're 1, 2, 3, 4, 5. I'll show you something neat about that in a minute. Okay. So now so this guy breaks the data down for you, but let me show you this. Now the next thing we're going to do is, why don't we explore the data? So if I come over here and, what kind of target do you guys have? Do you have a true and a false?
A 0 or 1.
Okay, so that's a binary target then.
Right.
Mm-hmm.
Okay, great. So let me look at the Explore. You're going to like this. Static guy here, he's on the Explore button. Third guy over, grab him. Let's run this. You're going to like this.
So is that pulling, is it linked directly to the data partition? Is it using like one of those components, the test or the...
Well, actually, he gets all three of them, but he's only going to use the training data for what he's doing.
Okay.
Okay, now take a look at this. So I run this guy, and I'm going to right-click and hit Results. And you don't care about any of this stuff. You just care about this output window. Watch this. This is going to, if you're falling asleep, wake up, because this is going to be cool. Okay. It gives you all sorts of neat statistics about this. But now we start getting down here, and he breaks everything down variable by variable. Take a look at this. Like, for example, let's take a look at how about the debt-to-income ratio? The overall average is 34, okay? And the mean average is 33. However, if you're a bad person and you don't pay me back, the average is 37. And the mean is 40. If you did pay me back, your debt-to-income ratio is 34, and the mean is 33. So I'm eyeballing this, and it looks clearly like this is a predictive variable because people who don't pay me back tend to have higher debt-to-income than people who do pay me back. So in other words, I spend my money on pizza and beer, and I'm not going to pay you back. But if I save my money, I have a low debt-to-income ratio, and I do pay you back. So do you follow that?
Yeah.
Okay.
Except there are a lot of missing values.
Yep, we're going to have to fix those. Okay?
Okay.
So let's do this. So anyways, so this is kind of cool. Now here's something else I can do. And every one of the icons, if I hit Edit Variables here, you see this Explore button down here? Every one of these icons has it. So if I come over here, hit Edit the Variables, watch this. So if you're falling asleep, wake up, because this is going to be another one that's cool. I'm going to highlight this, and I'm going to hit Explore. Okay, now, like I said, is you get to explore this data. Now, this is going to be so cool you can't believe it. Okay. Now, again, I get graphical representation of the data. I can look at the data, of course, but I can also alter these graphs. This isn't the cool part, but we're about to get there. But I can alter these graphs. So if I right-click and hit Graph Properties, I can say instead of 10 buckets, let's say I want 30 buckets. See, I can change this. Now, this white box here is the missing values.
Oh.
Now, that's not the cool part. Here's the cool part. The cool part is that this is an interactive graph. What do I mean by that? If I highlight any of this data, that same data gets highlighted everywhere else. so I can begin to look for interactions.
Oh,
Okay. Now,
that is.
but that's not even the cool part. Here's the cool part. Come up here to the wizard hat. If I hit this guy, and let me come down here and hit pi. Next. And let's say the job. So I'm going to go and set this to category. Next, 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 finish. There's the pie chart. I might want to right-click this thing, graph properties, the maximum slices. Let's do all 10 slices. Okay, so I'm showing salespeople, engineers, self-employed, managers, office workers, missing, and other. Okay, come over here, hit tile. Okay, and you're like, why did we just do that? Now remember what I said, this is interactive, right?
Mm-hmm.
What if I hit all the bad people? So I'm selecting all the bad people. Okay. Now let's take this guy and maximize it. The bad people are shaded in. Now you can see that more of the bad people are shaded in than the engineers. So do you think that a salesperson is more risky or less risky than an engineer?
What category would an engineer fall under?
This is the engineers right here.
Oh, okay. Professional. Okay. Well,
So,
it looks like based on the shaded area sales, but it's a smaller slice. So.
well, yeah, but that doesn't matter. The more salespeople are shaded in, so that means that if you're a salesperson, you're probably riskier than an engineer. Self-employed people are riskier than engineers. Why? Because if you have a sales job or a self-employed, you're more likely to get fired if you're not making your quota or your business goes under. So those are riskier jobs. So you can eyeball this and know that this is a predictive variable because there's a lot of different, variations in it.
Mm-hmm. That is cool.
Yeah. So here's another neat thing about this. Let me highlight these bad people again. You can always file this, save as, and then you can save it as like, jobs. And then this can go into your report. Oops, where did it go? Save as, let's put it on the desktop. See? And you can put that in a document.
Very nice.
Okay. Now, let's fix those missing values. We got some missing values, right?
Yeah.
So here's what I can do. Modify, impute. Let's drag that guy on the screen. And now how do we fix the missing values? Well, I fix the missing values this way. If I open it up, I've got a lot of different ways to fix these guys. I could fix it by the average. I could do a median value, maximum. These are all very powerful. Give those a shot. However, my personal favorite is to come down here and use decision tree imputation. And what does that do? Decision tree imputation means that what SAS will do is, let's say I don't know how much money you make. So we know that Jin makes $100,000 a year, okay? So we're going to just use that variable, no problem. However, Sharon, we don't know how much money you make, so we could just say the average is $50,000 and we could guess, and that's not a bad way to go. It's fast, okay? However, what if I know that you drive a Maserati and live next door to Johnny Depp? Okay.
I should be so lucky.
Yes, well, probably you make a lot of money, right?
Mm-hmm.
Okay, so you don't make 50,000. You probably make 5 million, right?
Mm-hmm. I would
Okay,
say so.
and then we say, well, Don Wedding drives a shopping cart, and I live in a cardboard box in the alley, okay? Well, I don't make $50,000. I probably make $5 a year. So this guy can intelligently guess, based upon other variables, what, you know, what your income is. And so he'll fix the missing values. So that's tree imputation is probably the best way to go. So I just, you know, set them all to tree is what I would do.
So is the variable that you're imputing your response variable in the decision tree and all other variables are being fed into the tree?
Yep. So what he'll do is
Okay.
he will build a decision tree very quickly to
Right.
figure out the missing credit line age, and this will be a target. And then he'll do, so he builds a bunch of decision trees on the fly where these are the target. Now he won't use this guy to figure it out because he won't know what that is at the time, but everybody else who's an input is fair game.
Got it.
Okay, so let me hit OK. And then there's one other thing, is sometimes the fact that somebody is missing is actually highly predictive. So you can come down here and where it says indicator, I would change that to unique and turn that to input. Now let's come over here again to utility. Let's grab another metadata node just to take a look at the data.
Can I ask you a question about computing?
Sure.
Two questions, actually. First of all, when you dragged that down, did you right-click on it to get to the menu where you changed it to tree?
Yeah, right click.
Okay. And then edit variable?
Yep.
So that's done after the data partition. Are these steps followed in the order that they appear here?
Yeah, this is I'm just giving you the order you probably are going to want to do it. If you just played monkey see, monkey do with this, I'll send you the data when I'm done.
Okay.
And you just build this, and then when you're done, just play monkey see, monkey do, throw your data on there, and get rid of mine.
Okay, I was wondering if you wouldn't want to fill in the missing variables before you partition the data.
Now, you'll probably, typically you fill in the missing values afterward, all right, because you don't want to in any way pollute your test data. If your test data is also being used to fix missing values, then it's somehow affecting your model. You want it to be completely isolated.
Okay.
The impute here will fix everybody. He will use the training data to fix, and then he'll use those models to fix the validation in the test data.
Okay. Thank you.
Okay. So if I come over here and let's hit run. Okay, just a sec. I got to throw something over here. Okay. So if I open this guy up, hit train, you see that it's a lot bigger now, right?
Yes.
Why? Because credit line age had some missing values, so he's rejected now. We're not going to use him. Instead, we've got the imputed credit line age, and this is the guy that we're going to use for now on because there's nothing missing. And we've also got this little flag variable that says, did I guess or did I know? So let's just highlight all three of these things so you see what I'm talking about. Credit line age, imputed credit line age, and then here's the flag.
So if we were to replace our 1.3 million rows, I mean, we can't do that, right? So we'll have to take samples beforehand.
Yes.
And then we would fill in the missing values of the sample?
Probably, yes. But I'll show you. Don't worry. When we're done, we're going to have some score code.
Okay.
Okay?
Whatever that means.
Here's the credit line age. And you can see I had some missing values. Now here's, let me make this graph a little bit more granulated here. Now if I click on this guy and highlight that data, you can see that SAS put the data in other buckets. He didn't just put it in one place. And he also has this flag set. So he said, if I didn't know your credit line age, I looked at other variables and guessed at your credit line age, and I also set this flag to true, which means I had to guess at it. Because sometimes a missing value is highly predictive. And this guy is rejected, but these guys are inputs. Now, we're almost done. Let's build ourselves a model. Step one, I would build a decision tree. Okay. Model, decision tree, drag them on here, connect them. Now, here's one thing you want to do with the decision tree. If you have a rare event, I would do this. Highlight the decision tree, come over to the left side, scroll down, and where it says decision, change that to left. Okay? That's about the only change you need to make. Now, this decision tree is completely interactive. There's so much you can do with decision trees. I'm not even going to go into it, but this is about as simple as it's going to get given the time you have, okay? So now the next thing let's do is let's see how good our model is. So hit Assess, and we're going to come over here, Model Comparison, drag him on the screen, connect him, and the next thing we're going to do is I would click on this guy here, the Model Comparison node, come over here to the left, do, whoops, selection statistic, let's use area under the rock curve. And let's change the selection table from train to test. So those are the only two changes you want to make. Let's run this guy real quick. It's going to start getting really cool in about 1 second. If this isn't cool, it's going to get cool.
It's already been very cool. So.
See, and every one of these boxes is just writing SAS code in the background for you, so you don't have to write it. Okay, so let's take a look at our friend, the decision tree. Highlight him, right-click, results. The trick with decision trees, don't worry about a lot of this stuff. Just dive in here and look at the tree. So we see that about 20% of the people don't pay me back, 80% of them do. If you have a debt-to-income ratio that is low, oh, I'm sorry, this is missing. So if your debt-to-income ratio is missing, then your chances of default goes from 20% up to 64. And that really means that you don't have a record with a credit bureau. So if you don't have a record about, it means you're probably hiding it or you've committed fraud. So that's usually why that's missing. But if you do have a debt-to-income ratio, in other words, you do have a record of the credit bureau, then your chances of default goes from 20% down to 8. So people who have some kind of a record are less likely to default. Then we look at your debt-to-income ratio. If you have a debt-to-income ratio that is low, in other words, you tend to pay people back, you save your money, your chances of default goes to 7. But if you have a high debt-to-income ratio and you don't pay people because you waste your money, your chances of default goes from 8% up to 94%. And if you want, you can look at, you just right-click and you can do View, 50%. You can see the whole tree if you want. And you can, of course, save it if you want. But that's not the point of this exercise. But you got a decision tree there. Now, if you look at over here, highlight this, right-click, results, And there you've got your rock curve. Focus on the chart. There it is. And you also have all the metrics here. So, you know, all sorts of different metrics. Now, let's, just for fun, what if you wanted to do a stepwise regression? So let's come over here, model. Let's get a regression. Connect him. And let's come over here. We've highlighted the regression. Let's come over here and do stepwise regression and connect it. And now let's hit run. Now what this guy's going to do is he's not just going to give you, he's going to tell you which of these two models is better. So you're going to let our decision tree fight with a regression and see which one was better. You want to guess?
Better than the one last weekend.
What was that? I didn't hear it.
That fight will be better than the one on TV last weekend, which I did not watch.
Probably. Who do you think's going to win?
Decision tree.
Okay, let's hit results. The answer is, nope, the regression was the better one.
Wow.
Maximize it. Focus on the chart. Look at that. Look at the lift differential.
Oh, yeah.
Now here's something kind of cool. Is, let me come over here and throw a neural network in. Here's a neural network. If you take, and this doesn't just work with neural networks, it works with any of the models. But if I take one model and dump it into the other, so what will happen is, you know, remember that I set this guy, I highlighted him, and I set him to stepwise regression? Mm-hmm. Okay? So what he's done essentially is he did some variable selection. If I dump him into the neural network, or anybody else, like I could dump him into a tree or support a gradient boosting model or a support vector machine. Where is that? That's around here somewhere. I don't know. I can dump them into anything I want. And if I hit edit the variables, take a look at this. This is going to be so cool you can't believe it. Look at this. Some of these guys are rejected. Why? Because the regression didn't use them. So the regression is used as a variable selecting tool for the neural network.
Cool.
Yeah, watch this.
I've been doing it manually.
Yeah, well, watch this. Tree. Neural network.
Mm-hmm.
And now watch this. One, two, three,
wow.
5. He only uses those 5 variables.
Holy crap.
Yeah, isn't this cool?
I didn't know you could do that. I've been wasting so much time going through each variable and manually rejecting them from other analysis. Oh, man.
Well, you didn't know, do you have access to Enterprise Miner?
Yeah, I made a bunch of model comparisons, but I've had variable importance measures, so I've been going through each edit variable and rejecting them manually.
But this only works with Enterprise Miner, though.
Yeah, I'm doing it in Enterprise Miner.
Oh, I see. Well, yeah, here's another one. You want me to show you some other variable selecting techniques? Okay, so
yes.
You could do this with anything. I can do this with gradient boosting. So gradient boosting, and let's let the gradient boosting select it for, I don't know, a regression.
Wow.
And Let me do one or two other ones. Watch this one. Okay, explore, variable selecting, select. Now watch this. Let's do that for, let's say, a neural network. And then I'm going to show you one other thing, and then I gotta show you how to deploy the model, and then I gotta go because my wife is gonna. We're supposed to have a movie night tonight. Okay, so watch this. This guy here will take each variable one at a time, and he'll decide if the variable is predictive or not, and he only lets certain people through. So he'll only let the predictive variables through. So these are all variable selecting techniques. You know, and people say, well, which one's the best? You know what? Be an analytic street brawler. Just let them all fight it out. They'll tell you who the winner is. You don't have to do that thinking. You let SAS do the thinking. Okay, one other thing, modify. Click on modify. We already looked at the impute node. Look at this guy over here, variable transformation. If you got any outliers, there's all sorts of things you can do with this. I'm going to show you the fastest one. Variable transform, connect, open it up with edit. Now watch this. There's all sorts of different transformations, like multiple and optimal binning and quantile and blah, 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 okay? Now, you're probably thinking, Don, which is the best one? You want to know which is the best one?
Mm-hmm.
Come up here and hit best, and SAS will try every one of those, and the best one he'll use.
I've been manually picking that too. Oh, geez.
Well, no, this is great, isn't it? So it only works for the intervals, though.
Okay.
But that's okay, right?
Right, that makes sense.
So hit it for best, hit OK, and then let's go to model, let's go to regression, let's connect it, let's change this thing to forward selection. Okay, there we go. And let's let these guys all fight it out. Analytic street brawl. Hit run. So we've got 1, 2, 3, 4, 5, 6, 7, 8 models are going to fight it out.
And fight.
Fight. Yeah, there you go. This is a good old-fashioned street brawl. This is how analytics should have been taught. You have the link from where you were putting your files. Just a sec, I got to give my... I have to send this link to... There we go. They moved some files on me, and I don't know where they went.
That's rude.
There we go. Okay, so here you go. Let's see who the winner is. Open it up, hit results. And we wait. There it is. So the best guy was regression number 3. followed by the neural network, followed by the regression, followed by neural network. You can actually name these guys, but let's just know that it's regression 3. Let's see which one that was. That was this guy right here, regression 3. He's the best.
Wow.
And you can actually open this up, of course, and look at the model, but you don't really care all that much. Here's what you really want to do. You want to score new people, right?
Mm-hmm.
Okay. This is where it's going to get so unbelievably cool that you're going to just be like amazed. Okay? Hit score. Bring this guy down here. So you've built yourself a model, right? If you hit score, do you know what SAS is going to do? He's going to go and he's going to ask all of these nodes on the winning path. So he's going to say, okay, Mr. Impute node, and he's going to grab the score code from this guy to fix missing values. Then he's going to come down here, since this is the winning path, and get the transformations. Then he's going to get the regression formulas. And then he's going to put it all in one big giant data step for you.
Oh, that's amazing.
Then you just take this guy, you hit Control A, you hit Control C, okay? And now, I can come over here, new SAS program, rename score code, and let me just open that. So I've copied it, right?
Mm-hmm.
And there it is. Now the only thing you have to do is come up here to the top and data, and let's call it 13 million. Score 13 million. So remember how you have 13 million records?
Uh-huh.
Mm-hmm.
Okay, so we're going to score them and set. I don't happen to have another data set, but let me just give me a second here. Let me just get the library statement. Okay, so let's just do this one, shlib.homeequity. So this is the same data set you just did. Okay.
Mm-hmm.
Then we come down here and hit run. So you have to put the data, the set, and then the run, and the rest of it SAS wrote for you. And this will fix the missing values, and we'll do the regression, and we'll do the transformation. He does everything. This is thousands of lines of code has been written for you.
That's awesome.
And if you just run a proc print this guy. So this is after you've got your data sampled. This is how you can score it. Data equals observation equals 10. Run. Okay, and watch this. In theory, this should run, and it will give you a score. So you can see, way down over here, the probability that you're bad is 73% for this guy and 88% for this guy, and here this guy's got a 39% chance of being bad. You see how that works?
Yeah, that's fantastic. So you
Isn't
could apply
this
this to any data set. You don't need Enterprise Miner. Like I could deploy this into base SAS or whatever data set I need it to be in.
Yep, you better believe it.
Wow.
And this is one of these tools that makes my heart happy. It's so beautifully well designed. It just makes me, and when I show it to people and they like it, it makes me happy because I love it and I want everybody else to love it.
Mhm.
So I unfortunately have to leave you ladies alone right now because I promised my kids I would watch the Witch movie with them tonight and eat popcorn.
What's the witch movie? Wizard of Oz?
No, it's not a witch movie. It's a movie called Witches, and it was written by Roald Dahl, who wrote Charlie and the Chocolate Factory.
Oh.
So he's got a witch movie, and the kids want to watch it. So apparently it's one of those movies that people not heard of, but it's supposed to be pretty good. But, we're going to watch it and eat popcorn. And they had me at popcorn. Although, I'm a sucker for a good witch movie. So,
Do you want me to send you screenshots of what I have available to me from purchasing the student version?
I would love that. And I'm going to send you, I'll send you the link for this in a minute. And then I'll also send you the data set. And I'll send it to you too, Jen, okay?
Thank you.
Thank you so much.
Do you guys have any questions? I mean, this is what I would recommend do is to just get started up with this quickly. Just monkey around with it and then get started, and then you'll have questions and you can talk to me and I can walk you through this stuff.
Okay, that sounds great.